Hello, I'm Eric Matisik, co-chair of Denver Startup Week. Last year, we were able to bring the global audience together for Denver Startup Week, and this year, we're excited to welcome that global audience back as we celebrate and showcase the best of entrepreneurship that the Denver ecosystem in Colorado has to offer, in Denver and beyond. There are lots to explore this week, but most importantly, we're excited that you're joining us. We have nearly 50 sponsor companies who contribute to make Denver Startup Week possible. Let's show our love for these companies today and all week long. Thanks to our headquarters and title sponsor, Amazon, and our title sponsors whose leadership makes this week come to life, Capital One Cafe, the Downtown Denver Partnership, Fluid Truck, Hotel Engine, and WeWork, and our track sponsors who've made all the great content you're hearing today possible, which includes our founder track sponsor, Kickstart, our growth track sponsor, Friday Health Plans, developer track sponsor, Quizlet, product track sponsor, Palantir, design track sponsor, Battery 621 and the Public Works, people track sponsor, Exactly, and the spotlight event sponsor, Strat Labs. Our headline event sponsors are bringing this excitement to the entire week. Thank you to B-Side Fund, Colorado Public Radio, Comcast, Coors Brewing Company, Denver Pavilions, Entrepreneurship at the University of Denver, Gusto, JP Morgan Chase, Method, Moss Adams, Pi Insurance, Promontory Mortgage Path, Red Bull Basement, Southwest, Tattered Cover, and the VF Venture Foundry. Finally, thank you to our sponsors and member sponsors who are listed on the screen, and thank you for your support of Denver Startup Week. Now, let's get to it.
Hey everyone, and welcome to Denver Startup Week. I am Michael Ostro, and I'm the Maker Track Chair, as well as a member of the Denver Startup Week Organizing Committee. Thank you so much for joining Denver Startup Week for our 10th anniversary. At Denver Startup Week, we strive to make all of our sessions a place where attendees can connect, learn, and grow, and that is regardless of age, gender identity, gender expression, race, ability, or sexual orientation. A special thank you goes out to our sponsors for their support and helping us make Denver Startup Week free for everyone and accessible to all. And I also want to thank Agora.io. They are the MakerTrack sponsor, so thank you, Agora, for making this happen. And thank you for joining us. Enjoy Denver Startup Week and make the most out of it.
All right, thank you all for joining us today. My name is Jenney Loper, and I'm the Director of Operations at Zebulon Solutions. Welcome to Denver Startup Week's Manufacturing Readiness 101 session. Since we're virtual, I'd like to get an idea about who we have joining us today. Could you take a quick minute and just put a word or short phrase about why this topic interests you or why you're here? Haley, who is monitoring our Zoom here, with us today, she'll just do a quick summary for us here before we get into our conversation. I'd love to hear who's joining us. A little bit about myself. I've been in manufacturing since I was about 6 years old. My dad started a machine shop on my parents' property, and he put me to work to burn parts and drilling holes from a very young age. After I finished my college degree, I have had a career in product development, quality engineering, manufacturing engineering, and supply chain management. I worked on products ranging from 75-ton wind turbine nacelles to high volume optical transceivers for fiber optics industry, multiple consumer products, as well as mid-range industrial printers. The session idea came to me really through almost every conversation or many conversations that I have with entrepreneurs. They're looking to take their minimum viable product, their MVP, and we use that acronym a lot today, to production. But by the time entrepreneurs reach out to me, they've absorbed a lot of misconceptions about what is needed to get the product into manufacturing, both time and money. This session is really my proactive attempt to head off some of those conversations and set you all on a path a little bit farther ahead to address the misconceptions that are out there. I'd like to talk about money first. A few months ago, I found this article about how much money is needed to start a successful company by Joe Copio. I put the main bullets on the slide, but in reading through the article and knowing what we know about manufacturing and what it took specifically there, these numbers are extremely conservative, at least for technology-based products. They may be more relevant for either software or application products, or it may be an extremely simple mechanical-only product. But as soon as you add a printed circuit board into design, your numbers go up pretty substantially. So, and then I think, I'm just gonna part my notes here. I think when I talk to people, I want to be sure that before they start spending any money, that they know what they're getting themselves into, and really knowing what their objective is for their business. And so, in thinking about when you have an idea or a product, what is your objective? Are you looking to start a business or run a business or sell a business? If so, your investment might be to give out $10 million. If you're looking just to license the idea, you're still looking at a pretty hefty investment of at least $500,000, if not $1 million, to really fully vet the design and get it ready for someone else to take it to manufacturing. All of the design and testing needs to be done. If you're looking just to have a side hustle, I really only recommend this for very simple mechanical only designs and really heavily invest in marketing. So talking about money, let's talk a little bit about time, because that's another area of misconception, and look at what the process that's involved. When entrepreneurs contact me, they usually have a rudimentary concept or maybe even a reasonably developed MVP, and they want to look at getting it into manufacturing. Most of the conversations center around, I just want to take this product and get it directly into production. One design cycle and we're ready to go. This is a huge misconception. The process isn't just taking the MVP into production, but it's designing the concept of something that can be manufactured. So there needs to be planned iterations, and to reduce the number of problems that happen when you're starting to ramp something up in volume, and also when you're handing it off to people who don't know your product and are usually unskilled labor. And so we'll revisit this idea of iterations later in our conversation today, but I want to plant the seed that what we're talking about is really manufacturing readiness. Our conversation today is going to focus on what happens between MVP and production, and it's not just one little iteration. The topics for discussion today is how to thoughtfully design a hardware or physical product for manufacturing, the necessity of planning iterations, how testing and failure reduces your iterations, and what kind of documentation is needed for manufacturers. I'm joined with a couple of my colleagues today on the panel. I'm joined with Chuck Hodges and Joe Steinman. Chuck is the co-founder and president and CEO of Zebulon Solutions. We're a Colorado-based company with a global reach. We work on a wide range of products, from 4,000-pound transformers to smart OptiPuffs to wearable medical devices. Chuck is a serial entrepreneur. He's founded and scaled up 5 startups, including one that was acquired by Flextronics. He held various executive positions there and has taken over 100 products in his career into production, including the Xbox, Palm Pilot, cell phones, optical transceivers. With over 30 years of engineering and operations management and a master's in electrical engineering from Stanford, he is an expert in product development. Welcome, Chad. Joseph Steinman is our senior mechanical engineer here at Zebulon. He's worked on products at Lockheed Martin, Plexus, multiple startups, including Tesla and NEC America. With a master's degree from Texas A&M, 10 patents, and countless hardware designs, his expertise in designing products to be manufactured is invaluable. So welcome, Joe.
Thank you.
All right. Before we get into the questions, I'd like to just level set our experience, because I know that within the Maker track, there's a lot of different people that are interested in manufacturing. Our experience is in technology-based products. It doesn't necessarily have to have a circuit board in it, but it needs to be some kind of technological innovation. What we're going to talk about will have some relevance to food and beverage or even fashion, but our focus is going to be on that technology and innovative technology. The format we're going to have is we have those 4 topics for discussion, and at the end of each topic, we will stop and pause for questions. If you have questions that come up while we're talking, go ahead and put them in the chat. Kaylee will get those asked to us in that little break between divisions. And I think with that, Haley, do you have any response on who's joining us today?
Yes, we have a couple. One person who is another costs steps of manufacturing.
Fantastic. All right. Do you want to start with the question, or do you want us to dive into our topic first, or which you know the question is? Okay. All right, great. Thank you so much. Welcome everyone. I'm so glad you're able to join us, really. So let's talk about designing for manufacturing. When you start thinking about how the product is going to be manufactured?
But really, from the initial concept of the product, you really need to know what, or have an idea what your product is and how you're going to build it in order to design it.
And anything to that, Chuck?
No, we usually try to think about it a little bit. I mean, there's a lot of other things you got to think about really early on, but, particularly on the mechanical side, plastic or titanium, uranium, there's a lot of issues there. And honestly, we should have discussions on cost too. I mean, it's idealistic, it's a great product. Software doesn't really have a recurring cost, but hardware always does. So anytime you use a product, you also want to talk about that, and you can't really have a conversation about cost without starting with it.
Sure. So you've started talking about this a little bit, but how does that manufacturing process factor into how the product is designed?
So, I mean, let's take a piece of plastic, for example. If you're molding a part, the process is are you going to start with what are you going to start with, right? How are you going to get the part manufactured as a prototype using alternative methods? Printed parts work well for that. And as you move through your phases, how are you going to refine that until you're actually ready for production tooling? There's lots of steps along the way. The end goal is where you want to be designing for, but you need to be able to make those pre-production, early production prototypes. So you're always thinking about that process along the way.
And I would add, you can get yourself trapped if early on you don't think about that and go, ooh, an aluminum extrusion, it's really cool, I like that. And then later on, 2 years later, the customer is in exactly the space right now. It's like, that's really expensive and doesn't do the industrial design that I want. You get kind of trapped into it. So you can easily, you make decisions in those very first days. So we want to spend a bit of time looking at the future and the cost it's going to be without constraining the early design process. That goal to get proof of concept out there, which is super important.
I think it's interesting that you bring that up, because there's a lot of entrepreneurs that get really wedded to a particular manufacturing process or design idea very early on, that then you get incorporated in and then rethunk several years later. I don't know if that's, you've seen that, or?
Oh yeah, you can get locked in. I mean, the reason we think about it is because we do lock stuff in, right? design decisions are made, product decisions, market decisions are made. They lock stuff in, and you don't want to have oops, I should have thought of that. That said, things are going to change and evolve, but starting to think about it early is going to some of your effort on that. And especially if there's novel processes. If it's as easy as using commercially available, easy stuff, simple circuit board technology, a couple of custom parts that screw together, it's easy. But when you start getting into really advanced products where there's something to challenge that's been done before, this increases exponentially.
So people are saying, Chuck, we can have Joe's microphone.
There we go.
Great.
Got it.
Chuck, do you want to first say something?
Testing. 1, 2, 3.
All right, it's not better on my end. If anyone else is still in the process, so it's
Okay, great, thank you. All right, so I think going back to what we're talking about designing for manufacturing, what needs to be considered in the design to make it manufacturable at higher volume?
So, I mean, the first thing really is knowing what your requirements are for your product. And that really defines or helps define where you're going to take the product in the design phase. You know, if you have something that's going to be submersible, that brings a whole set of issues that have to be addressed. If it's going to be exposed to complex environmental conditions, those have to be addressed as well.
Sit with the hockey stick.
Yeah, if it's hit with a hockey stick. So really knowing your requirements is probably the key factor into, or which leads into your design process and going from there.
And I would add, it's okay, and you really should think about it in the sense of what my must, wants, and nice to haves are at that point. You don't necessarily, it doesn't have to be all carbon concrete. Ideally, in fact, there should be areas where you can make trade-offs. You can trade requirements against each other. Those are your wants, and nice to haves. Musts are the ones that I'm just going to get out of this business if I can't get. But it's good to have a healthy dialogue there on those trade-offs and requirements. By getting requirements down on paper or a spreadsheet or however you want to do it, then you can have that trade-off discussion, and that can then be revised all the way through the development project as you get early on. It may be this feature versus that feature later on, and almost always comes down to, well, I save 7% of my cost if I jettison this feature. How badly do I want it? So it's a good methodology to use.
So when you're talking about requirements and the wants, the needs, and the nice to haves, wrong order, but anyway, you know, when would be a good time to start putting that down on paper and thinking about it? Because I know when I talk to a lot of entrepreneurs, they have a pretty good idea of what they want their product to do and from a general standpoint, but it's not written down anywhere. So when would you start thinking about putting that down on paper?
As soon as possible. You know, I mean, you're going to be needing to convey those requirements to the people that are doing the design, whether it's in-house or external, and they need to be understandable, and it's the best way to communicate that. And like Chuck said, having them broken up into the different categories, must have, want to have, nice to have, helps down the road when you get to, hey, I'm at 85% of the way there. Can I stop or do I have to continue? You know, having worked for multiple startups, 85% solution is what we strive for. And then we revise beyond that. So, but you've got to get a product out to the market as quickly as possible. And that's kind of where dividing it up goes.
I would just add that when you go beyond a team of one, it's important again. And certain startups start with, you are the entrepreneur. I've been that. Joe's been that. Jenny's been that. You do everything yourself. But once you start getting a team, it's tough to break those old habits of it's all in my head. And we see a lot of this with, you know, the CTO companies still keeping it in their heads, and gently try to nudge them to get it out on the paper. And it even helps you think about it, right? What do I really need?
All right. Let's see. I think we kind of already answered this. Let's see if you guys want to expound on this any further. But why don't we want to wait until we're ready for production? Like we think we've worked out all the details around what it needs to have, how it needs to behave, and then start thinking about manufacturing. I
mean, it's what you don't know about the product that's going to bite you, right? if you've designed it and you take it to manufacturing, and first thing they're going to say is, I can't build it. So, it's really important to engage manufacturing early on to get that kind of feedback to, save you time down the road and make sure that your product is built.
And I can add that some of the really great technologies that are involved over the past decade, like 3D printing, which really help us get products early on to the MVP and the alpha. But taking a design that's 3D printed is very different than a design that can be production molded or made out of sheet metal or whatever. Really different. And so you can totally trap yourself in something that you can build in low volumes, but you can't build in high volumes. So people get sophisticated. I mean, there's those fun tricks. We've all seen the 3D printed things with stuff locked inside and stuff. Really cool party trick, but that's completely unmanufacturable. So you can really get yourself in trouble because these, CAD makes it look like it's real. Your 3D printing makes it look like it's real. And so it's more dangerous now because these tools make you think that you've got something that's manufacturable, and sometimes they're just not.
Well, and especially when you're showing the product to potential customers, investors, whatnot, they see this and they say, "Oh, you're ready to go," and when really you've got 6 months or more to get it refined to where you can produce it.
If I can get on my soapbox for 1 second, everybody loves the 80-20, right?
Yeah.
The 85-15, but it's, the inverse 80-20 rule says that you've done 20% of the work, it looks like it's 80% done. But the inverse of that is that you actually have 80% of the work left to do. And that's great if you're trying to raise money and get the best valuation and stuff like that, but don't kid yourself into thinking you still have that 80%.
All right, great. Haley, do you have any questions from the audience?
Yes. What the difference between alpha, beta, and pilot prototypes?
Pilot? Pilot. That's all right.
Yes.
Pilot. Alpha, beta, and pilot. Okay.
All right, so alpha, everybody's terminology is different, but generally an alpha prototype is something pretty early. From an engineering point of view, it may still have bugs in it. In fact, it's what we use. This is an alpha one. It's alpha 1. You got to build one, test it, do a lot of stuff. From a market-facing point of view, these might be ones that you would show to investors and customers, let them play with it in a controlled environment. You're not going to sell them. You're not going to give it to them. You might let 2 or 3 customers use it for a week or 2. And by the way, if you're from the software world, there's very similar definitions there. Beta, and typically there can be several iterations of alpha. The first one may have white wires running all over it and a little duct tape inside of it. Beta is much more rigorous. Typically a beta prototype is built off the real manufacturing line, off of real tools. It's used for very formal validation testing, environmental testing, drop test, stuff like that. And then from a customer facing point of view, these you might give to early customers. You might sell them, usually you don't. And if you sell them, then usually has a please sign this, then you understand that this is a beta quality one. But these are ones you want to get in the field under very controlled, very friendly customers, controlled circumstances, but they should work like real units. But you probably wouldn't think of it as revenue. If nothing else, you're going to have to swap them out later and stuff like that. And then pilot is really the first step of production. Those are revenue, or you sell them. You're still making sure the production is going before you go to full speed, but it's that pilot production is
So it's essentially proving out production.
All right, that's a really good transition actually into our next topic of planned iterations. Haley, is there any one question that we need to tackle, or should we go ahead? Time to go ahead. Yeah, let's talk about supply chain towards the end, if that's okay. But I'll put
It is
that on
the
the
biggest
list.
issue.
It is, yes. All right. So we were talking about iterations already. We've done the definitions, so thank you, Chuck, for that. Thank you whoever asked the question for that great lead in. But I think that a lot of entrepreneurs I talk to, like I said, they have this idea. I have an MVP. Let's go to production. Let's just do one and done. Why is that not possible?
um, you're lucky to get it right the first time, and if you do, kudos to you, right? But the reality is that you want to design for that final part, knowing that you're going to have changes. You want to plan for time frame for those changes. Timeline is huge, because those changes could be very simple or they could be major changes depending on what you find in your early prototypes of production.
So when I started in the industry, dates back a little while, got great here. We simulated, we built bench level things. We did a lot of work up front in an effort to try to get it right. That's actually changed in the last 15, 20 years with the advent of, quick turn prototyping in various places. Very much matches the agile methodology from the software world that basically fail fast. I mean, get a product out, test it, and this applies at the product level and applies at the engineering level too. So we'll build something, test it, iterate. You can build, 3D printed stuff in a day. We can get today, there's issues with the supply chain, but normally you can get boards chain in a week. It is vastly preferable. I would actually challenge people to say, I don't think there's a reason to try to design right the first time. Make the iterations. The other things you learn tons of stuff in the testings. We do sometimes get people go, but if you're good engineers, you should get it right. And for those people, I would challenge you, find a leftover product in your house, open it up, find the circuit board inside of it, and look on it and see what the rev is. Usually in the bottom right corner, there's a little bitty box. There's tiny little letters that say Rev C, Rev D, Rev 4. I grabbed 2. This is Rev 6. This is Rev G. And I actually know it's G1, it's G2 as well. But nobody gets it right the first time. We don't. It's not that we're not good. If it's totally derivative product, maybe you're GM and you've been designing this board for 27 years, and you're making change for a model. But that's not the same. So just assume you're going to get some revisions and embrace, revise fast, get them out there, have your customers look at them, make sure they're doing right, test them.
So you've talked a lot about Rev G and Rev 6 or whatever over there. How many iterations should we be planning for when we start a project?
2 to 3 is what I plan for. The first is going to be your learning. The second is going to be your cleanup, and the final rev is going to be what is production in an ideal environment. Now, from a time frame and what you're touting, that's a good way to plan. If you can do it in 2, you're ahead of the game. If it takes 4, well, you're not that far behind the game, right? So.
I agree. I think 3 is a good starting point, but it does depend on how complex the product is and how bleeding edge it is. If it's bleeding edge, you can go into revs. And there's also sub-revs. On the mechanical side, Joe may 3D print 3 small sub-pieces of it before we get to it. Literally got a 3D printer in this basement, right? We got a CNC sitting behind Jenney, the big machine you can kind of see over her head there. Yes. So, a lot of those things are sub-iterations.
Yeah, I mean, when you're doing the design, if you run into a complex geometry or whatever mechanically, the first thing I go to is 3D print it and say, is this going to meet the requirements? Is it strong enough? What does it achieve? Or do I have to reiterate that? And those are iterations that are not ever really built per se as a prototype, but iterated quickly just to say, yes, it's going to work, but no, it's not. I need another correction.
And on the electronic side, the equivalent of that's white wiring. But
That's a G though. They had all the white wires on A and B, right?
yeah, but it's you make those kind of engineering changes real time, and there's lots of techniques today that allow us to do that pretty well.
So looking at iterations and understand that there's going to be changes, how do I know when a product is good enough? How do I know when it's ready to go into production? Do I have to get everything resolved? Does it have to be perfect? How do I know what to focus on?
That goes back to excuse me, understanding and knowing what your requirements are. The must-haves, want-to-haves, nice-to-haves. If you've met all your must-haves, then I say in your startup, then I say take it to market and get some feedback. Don't wait for the wants or the nice-to-haves. And maybe start. The whole key from startup, right, is revenue. And the sooner you get a product into market, the better off your chances of success are going to be. So.
I would add on to that, it depends on the class of product you're talking about. If something is an industrial product, if it's a medical product, people's lives are at stake, it's a whole different set of requirements than consumer. But even in the consumer market, I would ask myself, what are my customers going to think if I give them this product and it doesn't perform right? Are they a tolerant bunch? I mean, there are the gaming community, for example, is very tolerant of early stuff. They love to get their hands on the big things. If you're selling something for grandma, it might be a different game. So we understand that if we do go out with too early product, we're going to get fails, we're going to get returns. Are you okay with that? Are the impact of your brand manageable? I really like to think about it like that. And again, I would get it out there in many cases, but do them in a controlled way. Call it bait, let your customers know, backers or whatever, that they are testers. And sometimes you can convince them that this is a good thing. Maybe they're part of testing, debugging it. But just understand that anything that your customers test for you has a high likelihood that they're going to report back failures, problems, and how upset they can be. You can determine how that analysis.
We're going to talk about testing in just a minute. I want to pause right here before we do and see if there's any questions that have come in, Millie, for discussion.
We have one question about sort of iterations. Just wondering how if you're at sort of the final 85% of the design.
Well, I think we've more or less covered that, right? It's what we were just saying about wants, must have, want to have, need to have, depending on your market, what they would accept as a viable product.
And we'll get to testing in a minute, but I'd also say that you should be at 85%. You should have tested 85% of the stuff too. So if you're at, I haven't tested it at all, I think it's good, you're not at 85%. But if you've done most of the tests and the results are coming out pretty good, there's a few areas of concern. Oftentimes there's some tests that take a long time. Almost everybody says, okay, it's good enough, I'll try it there. But if you've done no testing on it, then you're not at 85%.
Well, and the other thing to think about is, can the product be upgraded in the field? A lot of times planning, putting hooks in, especially software firmware, that allows you to send out an upgrade to the field to correct issues is very beneficial. Earlier release of the product.
Easy to do in software, impossible to do in hardware.
Yes.
I would also say, put inside your head your own biases. If you've spent 30 years at GM, your definition of 85% done probably needs to come down a little bit because it started much faster. If all your experiences in other startups or at the university, add some extra testing to it. And so understand your own biases and experience. There's certainly people that come out of the corporate world that release way too late as a startup, but there's also people that have less experience or come out of the startup world that don't do nothing. Most of those that we see probably aren't 85%.
All right, well, let's go ahead and move it. So since we talked a fair amount about testing already, let's go ahead and get into that topic. Let's talk about terminology, because I know that when I talk to a lot of entrepreneurs, that when I say testing, it is very clear to me that we are talking about different things. So let's talk about what type of tests are there, what the purpose of those tests, and then we'll get into kind of why we would do them.
So, I mean, from beginning, right, it's just general form, fit, function. Beyond that, you're looking at engineering verification tests, and then manufacturing or the validation tests, which are more stringent, and then production-based tests. So those are kind of the broad categories.
Those are all very product-centric on the side of things. We're not talking regulatory or certification on any of that.
Once you get past the engineering and into the verification, yeah, you are actually looking at agency testing.
And I said the first sequence of those are things you can do on the design. Does it work in general under design controls? And then production tests, which we'll come back to in a second, is a whole different animal because that's each widget that you build, how do we test that? But the upfront stuff, I mean, you start out with very simple stuff that Joe says, function, get it to engineering verification, which really doesn't meet my requirements. Yes, yes, no, yes, no, yes. And then the more formal testing, I like it. It's 5,000 hours at night, high humidity. I do a test it. And your common regulatory falls into that general category, although it's in its own world. Safety, agency approvals. If you sell to the EU, CE market is actually got some very strict requirements. The US is easier, but there's standards. Japan standard, China standard, all have very different regulatory environments. And medical, automotive.
So knowing what industry you're selling into is going to dictate what regulatory testing and agency testing is necessary. But regardless of industry, there's some very standard tests that need to be done to develop the product relative to the product specifically.
And even a consumer product, I mean, drop test is a really obvious statement. People are going to drop this. Are you okay with it? If it breaks, if so, don't do it. If you aren't okay with it breaking and consumers send it back for returns, then you probably have to do some testing. Temperature testing also is kind of must have, even for consumer products. If they're using it in Florida, super hot day outside and high humidity is a different world than we're here in Colorado winter and we're doing this in the garage. So you need to understand at the very least the temperature. And so there's kind of a minimum set of requirements that many products have much more stringent requirements, and that's dictated by testing. It needs to survive in a humid environment. We need to test it. Joe's submersion one is a little extreme, but there are many, many products that are used outdoors need to have protection from water ingress. Or if it's a wearable, your skin, sweat. Sweat is actually really worse than rainwater. So lots of issues.
So one thing that I hear from a lot of entrepreneurs is that testing just takes too much time and they would like to skip over it. They're in a time crunch. And I hear that they really want to just get it manufactured first, get some revenue generated, and then test the product. What are the pitfalls in doing that?
I think it's tied to the earlier comment about how talented your customers are. If you're asking your customers to test the product, it's a valid strategy, but then understand that a significant percentage, perhaps all of them, are going to come back. Are you okay with that? I've known companies that have been okay with that, and they made a conscious decision, and they basically budgeted, I'm going to replace all those products later on. These are valid strategies, but understand if you don't test it, almost certainly there's going to be someone's going to come up with problems, and Joe in the lab finding that problem here is a lot less expensive in cases than having your customers write that use for you and send the product back. And of course, things like where the product might hurt them, might burn their house down. There's issues like that that are way.
I mean, yeah, safety issues number one, right? I mean, UL testing or related to that or equivalent is key if the product is plugged into a wall, for example. There's safety issues associated with that. Cellular, Bluetooth, any kind of device that transmits data, there's issues there that a lot of cellular companies won't even allow you onto the network unless you've done some level of testing. So
Pretty extensive.
Yeah. Yeah. So I mean, it really depends on your product as to how far you should or shouldn't go prior to handing it out to the customer.
How do you figure out what tests need to be done?
Pretty much anything electronics needs to go through a UL type of test.
Exception being if it's got a.
Yeah. But even then, I mean, devices with batteries have to have a certain amount of testing as well. So, just assume that there's agency testing associated with any kind of electronics product, or even toy products for that matter.
Toys have heavy regulatory.
Heavily regulated due to the age group of the children that it's intended for. And so, kind of the best way to see which testing is required is to get engaged with the testing house. And there's several here local that can assist. But basically, it's here's our product, here's our intended audience. What testing do we need to do to get certifications?
And I would also, though, pop up a level, start with your requirements. Find a good set of requirements and look at each requirement. Say, what do I need to prove that requirement? It's supposed to operate outside. That means what temperature? Okay, we defined a temperature. Now I should probably test it against that temperature, right? Your requirements can guide a lot of your testing. In your use cases, some of these are how to handle it, but talk to your use case engineers and figure out how to mimic what they're doing. There's no exact science. There's no if this, then that outside of some super regular military and medical health. Very exact. But most of the time, there's some gray zones for us. But if you don't do it and your customers test it, they're going to be very expensive.
So thinking about money a little bit and going to the labs agents and going to the labs can be very expensive and costly to do that. Are there tests that either I as an entrepreneur can do, or I can have an engineering firm do for me, or the designers or whatever do, that would be a little less costly than hiring a lab to do, for example?
Oh, absolutely. There's many shades of gray, but it depends on the test. For example, a mechanical widget that opens and closes, it's got a hinge on it. You can pay somebody minimum wage to do this 100 times, 1,000 times. Companies like us do this. We've done that kind of testing. Drop testing is an easy thing to do. There's a few caveats on which corner you drop it on. Here you drop it in the first quarter. I often would say do pre-testing that way. We do a lot of pre-testing in our lab. You can't quite see it because we've screened it out. We have several hundred sensors in the lab right now for one of our clients that we've been tested on for a month. We have a chamber behind Jenney that we temperature tested on. And it's a simple chamber. It's the kind of chamber that perhaps a startup might invest in. But when you get to the point where you want to test 100 at a time, that's not big enough. So right now we're doing testing in a lab aisle down the street, a much bigger chamber. It's 5x larger than ours, that we can test many products in rather than just a few. So there's a lot of stuff you can do in-house, and there's some things you don't have the expertise with the equipment. You need to do shock and vibration testing. You don't really want to invest $150,000 in a bike based on the
But I mean, the key that Chuck mentioned there is that you want to do pre-testing, right? You want to be confident that your product is going to pass before you actually say to an agency, here, go test it. Now, that's like I said earlier, though, you want to engage with the agency to make sure that you know what tests they're going to do. And you want, but before you hand it over to them, you want to be pretty confident that you're going to pass all the testing, or you're throwing money down the drain. So,
I love the testing. You should always, you don't necessarily have to pass your test, but you know which ones you expect to pass. And especially the final regulatory, but that type of test, the heck that it should be. But early on, we expect failures.
So don't take my new product I just designed and take it to the agency test lab, do all the pre-testing first to get the failures understood and driven out before you go pay the money.
yes, absolutely. And a lot of labs will allow you to rent the lab for a day or whatever, especially EMI labs. And so you can go in there and do all of your testing with your assistants and find the issues, find out how to solve them before you actually send it off to the agency.
Haley, do we have any questions about testing? Failures?
Joe S. Question is, how do you design this functional testing?
Okay, so
Mechanical,
functional testing, I'm assuming we're talking production tests here. And really, it's designing to support the product in a way that's conducive to manage the test, be it physical tests or electrical tests.
So I actually, Jenney mentioned, I was part of a startup that got acquired Flextronics, and we did lots and lots of tests. And it was the biggest effort there over the years was growing their test group. We did the test systems for Xbox and pilot cell phones, all sorts of fun stuff. And it depends on the product, I'll say to start with. At a minimum, if you've got a circuit board, you need some way to touch the circuit board to get connections. In high volume production, you don't want to be plugging cables into it, so we almost always build it that enables type of fixture that will access it. We also can write software that exercises the widget to make it do it. More physical things that move and stuff like that, you've got to figure out a way to do this that makes sense in a production environment. But the fixtures can be very simple or they can be extremely complicated depending on the product. RF is its own world because you shield it from cell phones. So there's a lot of complexity there. Certainly say it's a case-by-case basis. There's established techniques for circuit boards. There's in-circuit test ICT that is more standardized than others, but oftentimes you'll do that at the board level to get rid of manufacturing defects, and then have a functional system which mimics whatever the widget is supposed to do and what it's supposed to sense, controls motors, attach a motor to it.
Yes. So the key is really, what is your testing strategy? Are you going to do everything at the circuit board level and assume that it all works when you plug it together? Is there, circuit board level stuff that needs to be done as well as top level before you ship it out the door? All of those levels add cost, but on the flip side, the earlier you can test, the earlier you're going to find the problems, and so your scrap rate is less.
On the question of cost, I always like, especially for products that are headed to some type of volume, I like the idea of over testing early on, build more fixtures to get it going. And then as you scale up, hopefully scale back the testing, which means your true cost, you spend 10% more on your early products, but you can lower the cost with the numbers that big, and also it means you don't have to buy hundreds of test systems. We built over 500 test fixtures for Xbox launch because that's a giant launch. But you don't really want to do that for most products. So if you can start with over testing and then scale back, because if it never fails to test, you feel pretty confident that.
Yeah, is that test doing anything for you, and based on your failure rates and whatnot, you can make those decisions. But it's better to test it early in the process.
So planning for when we're starting production, maybe we'll have more tests that are going to be necessary on the manufacturing line to ensure that product going out the door, it meets the requirements. And as yields show, or that you never get failures off a particular test, you can dial that back, save some money on process, and then we'll just have less testing for whatever necessary for the product. It's been designed well enough to pass that particular test.
Absolutely. Yeah.
And you'll have statistical data of that.
Correct. So that's after we started production. But yeah, so going in. Right. I want to move on to the next topic and talk about what documentation is needed for manufacturing. Before I step into that, I actually want to wrap up one thing about testing, and that is a lot of entrepreneurs that I talk to don't really take into consideration that their manufacturers are going to need a way to test the product. And in as much as they want to take their MVP and get it directly into manufacturing, there's been zero thought at all about how that product is going to be tested in manufacturing. So from a readiness standpoint, having that test piece that you can hand off to your manufacturer is paramount to ensuring the product going out from your manufacturer is meeting all your requirements. And so looking at what the documentation that the manufacturer is going to need, let's talk about the type of documentation that exists in the design world and what of that needs to be created or can be used in manufacturing. So let's start with CAD, for example.
Yeah, I mean, from an engineering standpoint, you're looking at critical requirements, what needs to be conveyed to your manufacturer, to their quality people who are inspecting this. I can go get a part built directly from the CAD files. And the problem is that, inspecting that, somebody's got to be manually interrogating the CAD file every single time in order to create, in order to do the inspection. So key things here are really not so much what's necessary to build, but what's necessary to inspect and verify. Critical dimensions, interfaces between multiple parts, for example, are key. If you're doing molding, you really want a handful of dimensions that will tell whether your process is working or not. So, overall dimensions are key. Mounting point dimensions are a good way to convey that. And all that needs to be in the drawing so that the manufacturer understands what's required. Now, do you need every single dimension on that drawing? Probably not. Back in the 80s or 90s and prior, before the data transfers with CAD were available, yeah, you had to have everything defined. But now with transferring data, it's much less necessary.
So you still have to have drawings, but you can rely a lot more on CAD than you could, but you can't have zero drawings.
Correct. Yeah, you have to have something that at least says, yes, the part was made right, or reasonably assured that the part will fit the next levels.
And I think that's, to me, the real key why we do this is fitting together to the next level. If this part is off by a millimeter, and the next part's off by a millimeter, and the next part's off by a millimeter, we can still fit together and do whatever it needs to do. At one level, it's a passive thing, but think about gears and stuff like that. If those things are off even a tiny amount, the product stops working, the gears bind or they slip. So that's a real good example of why you need this. And we see this a lot. I mean, honestly, this is the number one issue that we see with somebody coming in and saying, I think we're ready, is fusion drawings. And so many people say, no, I've got CAD. You just have to remember, CAD only conveys the nominal. It conveys the nominal really well, perfectly, in fact, but nobody can build perfectly. You can't, and especially, again, if it has a complex tightness of tolerance and choice and stuff like that, those tolerances stack up and discover that you can go there, provide a CAD, and start building statistically significant numbers. So,
yeah, I mean, during the design phase, even at alpha, I try to have some level of documentation that I send along with the CAD. I mean, you've got to convey materials, you've got to convey critical dimensions, like I said. And again, it's not everything, but it's a starting point, and it helps convey the design intent.
and if you're consumer product centric, and there are a lot of startups and folks perhaps on this call are thinking consumer type of stuff, when you think about the surface cosmetics, those have to be conveyed in drawings or constructions as well as what it's supposed to be. It's like it's supposed to look good, right? But that needs to be conveyed. Color, oh my gosh, you can have color and sheen and stuff like that, right? So all of that has to be conveyed.
So one thing you touched on a little bit has to do with nominal intolerances. And one of the questions or conversations that I have with entrepreneurs a lot has to do with, why can't the manufacturers just make everything perfect every single time? If I have a good manufacturer, why do they need tolerance?
They also say the same thing about test. Just build it right, test. But in reality, even quality manufacturers, there's limits on everything. Every piece of equipment that makes something has tolerances associated with how good it can be. If your tolerances in your system are really lax compared to the tolerances of the equipment, you can get away with this. And there's a lot of really cheap products that don't worry too much about tolerances on. But if you're running your equipment and do tolerances to 1,000th of an inch, and all you care about is the nearest inch, you're fine. Right? But most products aren't like that, and there's no magic involved. You can't magically do exactly the same.
Well, but every machine has tolerance, right? And think of backlash between gears on a mill or a lathe, right? And there's tolerance there. So, no matter how good you are, you're going to have some variation from part to part.
I would also say on the business side, this is super important too, because the drawing, the tolerances are how you also get into the discussion of, did you set the bad part or not? So if you're expecting them to build good parts, this is the definition of good. It's whether it meets the drawing. And in reality, this happens a lot, right? You get a bunch of parts, they don't quite fix. You go, oh, I'm going to get upset at my vendor and tell them that they owe the money back or parts or whatever. The way that that's conveyed in the manufacturing world is, did it meet the drawing? If it met the drawing and still didn't work in your system, you don't have much ground to stand on. On the other hand, if it doesn't meet the drawing, you have a very strong case for refunds or business restitutions. So it's very important that conveys just doing it to CAD. And kind of they love it if you just say, just do it to CAD. Some of them, though, because they're off the hook. They can do whatever. I mean, you have no recourse against them. So from the business side, it's important to convey this.
So we could probably spend an entire session talking about cosmetics and documenting what is the definition of good. I've actually spent weeks of my life working on what is the definition of good relative to appearance, but we don't have time to digress into that. We did have one question early on about supply chain, so I do want to go back and revisit that quickly before we wrap up today. So what was that question?
Yes, so we had Brian asking since supply chain, like we were saying, well, sourcing is going to be more important. So just speaking on what sort of local sourcing manufacturing range, what sort of
So I hope it's never the same. I hope that that's not true, that we never get back to the state of the supply chain. But certainly it's messed up. And for those of you who aren't aware of this, I mean, the global supply chains for everything are just a disaster. And it affects stupid little things like capacitors and boards, it affects materials, fasteners, everything. And it's slowing people down, and we spend enormous amount of efforts now chasing parts to populate these parts, chasing, and it can be several layers. I mean, Joe was dealing with a very reliable metal shop, but they couldn't get the stainless that we had called out to build the part. They had capacity to build it, and they were a US-based company, but they couldn't get their stainless. So PEMS is a tiny little fastener that gets embedded. In fact, we'll need to detail inside of things like plastics. I think we have 10,000 of a particular one, of which we do several hundred. We only buy 10,000 quantities. And they're essential. So supply chains are a real mess. Macro level, without addressing, I'll come back to the question in a second, but worry about this right now. And this part of worrying about manufacturing right now is worrying about supply chain.
If you find the part, can afford to buy it in quantity, basically do so, because a week from now you might not be available.
But back to the finding local suppliers and stuff, I think this is always in favor of keeping supply chains local, but remember also that they're subject to getting their materials from the global supply chain. So it's not just your supplier, it's their supply chain. So if you're using a machine shop here and you're using stainless that's coming from China, that doesn't necessarily help here. So you have to really spend more time thinking about that sort of supply chain. The plastic resins that go into plastic parts, we've had projects held up. Jenny's pulled some hair out on that one, right? The resin that normally is always in stock everywhere in the world doesn't exist. So this is a huge challenge for all of us. And I would spend time and think about it several layers down, because you can get yourself convinced, well, I'm buying from Joe down the street, and Joe down the street isn't buying from John next door. John next door is buying from Jane, and all these people have their materials. There's issues.
I think the key is to get involved with your suppliers early to understand really what's going on with the parts that we need.
Circling back to the very beginning, that's probably the biggest reason to talk about manufacturing sooner rather than later today. It's number one. It shouldn't always be the case, but right now that's the number one.
Well, thank you both for this conversation today. We're about out of time. I know we could probably spend another hour talking about supply chains and other things manufacturing. Haley's going to put a slide up on the screen and then put a link up for you all. We would love to continue this conversation. You can reach out to any of us at info@zebulonsolutions.com. Haley will put that up in just a second. And then there's also, if you're not aware, there's a Slack community just for physical products. It actually came out of Boulder Startup Week. And if you're interested in joining that group, the link will go up, and you can just click on that. if you have technology issues, then just reach out to us at Zebulon Solutions, and I'll get you contact there. We would love to have a virtual coffee about your product, about your questions. We'll even meet in person at this point. You know, we can do that these days. And I think that's all I have to say. I'll leave that up for a minute. And Haley, did you put that invite in Slack? Chat? Fantastic. All right.
Scooch over and apologize for technical issues here. And I know we didn't get to all the questions, so if you have questions, you can Slack link or email us. And yeah, hopefully I covered what everyone wanted.
Yeah, if we didn't get all your questions answered today, please do send them to us in email, and we will reach out to you separately. So I think with that, thank you, gentlemen. Thank you, Haley.
And thanks everybody for all the good questions. It's great
Thank
to have
you.
an interaction on these.
That's fine.